crystalline solid classified into 4 types. First type is molecular solid, second type is ionic solid, third type is covalent solid, and fourth type is metallic solids. Molecular solids are further classified into 3 types: non-polar molecular solid, polar molecular solid, and hydrogen bonded molecular solid. We see first type, that is molecular solid. In that, non-polar molecular solids, they are made up of either atom, and that atoms having similar electronegativities or small electronegativity difference between that. We see the example of non-polar molecular solids: H2, Cl2, F2, Br2, CO2, CCl4, methane. All are examples of non-polar molecular solids. In this, the hydrogen atom is there, Cl atom is there, F atom is there, Br atom is there. In this, carbon and oxygen atom is there. Here carbon and chlorine atoms are there, and here in the methane the carbon and hydrogen atom is there. These all are the examples of non-polar molecular solids, and the atoms are present in these examples having similar electronegativity or small electronegativity difference. Here the first 4 example, that is H2, Cl2, F2, Br2, having similar electronegativity because having same atoms. In CO2 and CCl4 and CH4, atoms are different, but they are having a small electronegativity difference. In non-polar molecular solids, the composed atoms or the molecules are held by weak dispersion forces, or that force is called as London forces. The atoms are, or the molecules in this non-polar molecular solids are joined together or held together by weak dispersion force, or that is called as London force. Non-polar molecular solids are soft and non-conductors of electricity. They are soft in nature and they do not conduct electricity. They have low melting point and usually exist in liquid or gaseous state at room temperature, at room pressure. So in the atmospheric pressure, in the room temperature, these non-polar molecular solids are exist in liquid form, or it is present in a gaseous state. Examples we see above also, and here we see how that is aligned with each other, or they are linked with each other by sharing and pairing of the electrons. They complete their duplets and form the bond between that is called as covalent bond. Here the covalent bond is there, but they are non-polar because this molecule is joined with the another H2 molecule. So in between the molecule and molecule there is a bond, and that bond is called as London force or weak dispersion force. So in non-polar molecular solids, the molecules are joined by weak dispersion force or London force. Next type of molecular solids, that is polar molecular solids. So the headline give the idea about which molecule is present in this solid. Polar molecule is present, that having a polarity, negative pole and positive pole in that. The molecules like HCl are formed by polar covalent bonds, because here polarity in HCl and SO2 due to presence of high electronegativity difference between the bonded atoms. Here the bonding atom between that there is having a high electronegativity difference, that's why they are having a polarity. Hydrogen here more electropositive and chlorine here more electronegative. That's why the molecules or the solids from that molecules is called as polar molecular solids. In polar molecular solids, the atoms or molecules are held together by strong dipole-dipole interaction. What is dipole-dipole? Polar molecule has 2 dipole. So polar molecule joined. That's why polar molecule has 2 pole. That's why polar force. That is dipole-dipole interaction. Interaction means there is a force of attraction. So there is a dipole-dipole force of attraction, that is bond is present in between these polar molecules in this solid. They are soft and non-conductors of electricity. The melting point of these polar molecular solids are higher than those of non-polar molecular solids, usually exist in liquid or gaseous state at room temperature and pressure. These polar molecular solids having higher melting point with respect to non-polar molecular solids. At room temperature, they exist in a liquid or gaseous state. Other examples they given in the upper para also: SO2, sulfur dioxide, ammonia, ethanol. These are the other examples of polar molecule. Third type of molecular solids: hydrogen bonded molecular solids. Hydrogen bonded molecular solids contain polar covalent bonds. Between hydrogen and electronegative atom like fluorine, oxygen or nitrogen atoms. What is hydrogen bond? The bond between the hydrogen and electronegative atom. See what is meant by hydrogen bond? The bond which is between the hydrogen atom of one molecule and electronegative atom of the other molecule. So in this molecule there is polarity between the hydrogen and electronegative atom. So in this solid polar covalent bond is present. Strong hydrogen bonding binds the molecules of such as like H2O. Strong hydrogen bonding binds the molecule of solids like H2O. So in the H2O, the H is hydrogen and O is electronegative atom. So hydrogen of one H2O and oxygen atom of other H2O, they are linked by strong hydrogen bonding and they are bind and form the ice. They are non-conductors of electricity. And are volatile liquids or soft solids under room temperature and pressure. Examples: this is the water molecule. In this water molecule, this hydrogen is partially positive and this oxygen is partially negative. This is also hydrogen, that is partially positive. The oxygen atom of one water molecule is joined with the hydrogen atom of other molecule. Oxygen atom of one water molecule is joined to the hydrogen atom of the other water molecule, and this is nothing but the hydrogen bond. Second type of crystalline solid, ionic solids. The name says that there is a bonding between the ions. There are two ions, one cation and another is anion. The constituent particle of these solids are ion. These solids is composed of three-dimensional arrangement. So these crystals having or this solid having three-dimensional arrangement of the cations. What is cations? The positively charged species, and anions, that is negatively charged, that are bonded by strong Coulombic forces, or that forces is also called as electrostatic force. Repeatedly see this. The solid, that is ionic solid, is composed of three-dimensional arrangement, 3D arrangement, and in that there is an arrangement between the cations and anions. The cations, we know that positively charged species and anions negatively charged species. That cations and that anions in the ionic solids are bonded by the strong Coulombic, that is electrostatic force. So in this ionic solids, the cations and anions are bonded by a strong Coulombic forces. These solids are hard and brittle in nature. They having high melting and high boiling point. They are electrical insulators in solid state. In the solid state, these ionic solids do not conduct electricity. Why? Due to the absence of movement of free electrons. In solid state, these solids do not conduct electricity. Reason behind that, absence of movement of free electrons. There is no movement of the free electrons. There is a free electron will be there, but there is no mobility to that because of the solid state. But ionic solids are good conductors in molten state or in aqueous state also, due to the movement of ions. In molten state, in aqueous form, in these solids, there is a availability of, or there is a freedom for that free electrons to move anywhere in the solution or in the molten state or in the liquid form. That's why they are good conductors in that particular conditions. So in solid state, they do not conduct electricity because of the absence of free electrons. There is an absence of movement of free electrons, but they are good conductors. In molten state as well as in aqueous forms due to movement of ions. Ionic solids, here sodium donates the one electron to this chlorine and complete its octet by donating the electron. That's why it becomes a positive species, and chlorine accept that electron. That's why it is a negative species. That is a cation. Sodium forms cation deficiency by the one electron, and they are one electron rich species Cl minus. Both are connected with each other by negative positive poles, and they form is called as ionic solids. And in between that there is a presence of bond. That bond is called as ionic bond. Third type of the crystalline solid, that is metallic solids. The words say that metal. Here we see in the picture plus plus plus, the circle in the plus. So these all cations are metals, and here in between this here in the interstitial position of this solid there is a presence of negative species, and that negative species is nothing but electrons. So in the first point of this metallic solid, in these solids positive ions, that is metal ions, is surrounded by mobile free electrons. That free electron become mobile, so they are go anywhere in this solid and are eventually spread all over the crystal. These electrons are spread all over the crystals as like a sea of electrons. So here in the metallic solids, each metal atom donate one or more electron to the group of mobile electrons, which increases the electrical as well as thermal conductivity of metallic elements. Each metal atom, so in between this metallic solid, each metal atom donates one or more electrons to the group of these mobile electrons. So the number of electrons increases, and the number of electron increases, their electric conductivity, their thermal conductivity is also increases. Application of electric field makes these electrons flow through the linkage of positive ions. So electrons are, the electric field is developed here due to the flow of electrons, and that flow of electron is caused due to the positive species, that is positive ions, because electron is a negative species and is a positive species, so they are attracted towards the positive species. So there is a flow of electron, there is a development of electric field in our metallic solids. Whereas application of heat to one portion of metal makes the thermal energy spread uniformly throughout by the free electrons. In above point we see the electric conductivity of the metallic solids due to the flow of electrons by linking with the positive ions. In this point we see that there is a flow of thermal energy uniformly throughout this metal due to the free electrons. So in above also the electric field developed due to free electron flow, and here also there is a flow of heat. There is a flow of heat due to the flow of free electrons uniformly throughout the metallic solids. Presence of free electrons in metals makes them lustrous. In our first lecture we see this point, the presence of free electrons in the metals makes them lustrous, and the reason behind this is also the free electrons emission when the one light is incident on these metals. Malleability, and we know that this malleability as well as ductility to the metallic solids. For example, chromium, iron, etc. Last topic or last type of this crystalline solid is covalent bonds or network molecular solids. Covalent bonds, molecular solids, or network crystalline solids. This crystalline solid containing which species? Non-metals, and they are bonded by which bond? Covalent bond between the adjacent atoms. They are very, very strong and directional in nature. Why? Due to the atoms are held very strongly at their position all over the crystal. When these are bonded with each other, they having a directional in nature because they are bonded very strongly at their position all over the crystals. They are also called giant molecules. These solids are very strong and brittle. They have extremely high melting points and may decompose before melting. They are insulators because they form from non-metals. and do not conduct electricity. Diamond and silicon carbides are typical examples of such solids, but graphite is an exception because it is soft and a good conductor of electricity. What makes the graphite soft and a good conductor of electricity? So we see the question on this. What makes the graphite soft and a good conductor of electricity? The graphite is a covalent solid that acts as a good conductor of electricity and is soft. The carbon atoms of graphite are prescribed in different layers and are covalently bonded to the three of its surrounding in the same layers. The fourth valence electron of each atom, each carbon atom is present between the different layers and is free to move, which makes graphite a good conductor of electricity. I will summarize this why the graphite is soft and a good conductor of electricity. In this, the graphite containing carbon atom, and in the carbon atom of the graphite having 3 valence electrons utilization, but 1 electron will be remains behind, and that 1 electron in graphite they are free anywhere in the body. That's why they are the good conductor of electricity. The characteristics of sliding between the different layers makes graphite soft. The characteristics of sliding between the different layers, there's different layers are in the graphite, so they are sliding one over other. That's why the graphite becomes soft and is good solid lubricant, and they use as a good solid lubricant because there is a different layers present in the graphite and that different layers are sliding one over other. Thank you very much. If you like this video, give it thumbs up. For upcoming video notification, subscribe now my channel. And finally, thank you for watching my video.